Imagine you're sitting at your desk. You slide your mouse an inch to the right.
Right.
But the actual computer calculating that movement isn't under your desk. It's sitting in a sealed, hazardous bunker like 6 miles away.
Which is wild to think about.
It really is. Welcome to your custom deep dive. Today we've got the highly technical product specs for the Smart-AVI P2P-KVG300 IPGard extender.
That is a mouthful.
It is a massive alphabet soup, but our mission today is to figure out how industrial-scale remote control actually works. Like, why are companies spending $1,444.15 on what is basically the world's most over-engineered extension cord?
Yeah, but it really is the ultimate extension cord. In the tech world, they call this a KVM extender.
Keyboard, video, and mouse.
Exactly. Its core job is to take your high-definition monitor, we're talking DVI video, up to 2560 by 1600 resolution, plus your USB 2.0 devices and audio, and just funnel all that data over a standard gigabit network.
Okay, let's unpack this. Moving a mouse feels instant to us because, the cable is only 3 feet long.
Right.
But the spec sheet says this device uses something called JPEG 2000 compression to keep things instant over these huge distances.
Yeah, it does.
Wait, compressing video usually adds lag, right? If I'm trying to control a machine, wouldn't forcing the system to, compress the screen image make my mouse feel really sluggish?
That's a very intuitive catch, actually. But here's why it makes it faster. Raw, uncompressed video data is just massive.
Right.
If you try to shove all of it down a network cable at once, you get this massive digital traffic jam.
Oh, I see.
So the JPEG 2000 standard compresses each individual frame of video so efficiently at the hardware level that the file size shrinks dramatically.
Smaller files move faster.
Exactly. They move much faster across the network, and the extender on your end decompresses it instantly. The result is you just don't feel the delay.
That makes sense. Shrink the cargo to speed up the delivery.
Precisely.
But let's talk about the actual delivery route, because the distances in these specs are, frankly, staggering.
Oh, they are.
It says you can push this signal 328 feet on standard CAT5, so just regular copper network cable.
Yep, your basic Ethernet cable.
But then, if you switch to multi-mode fiber, it jumps to 1,640 feet. And if you go to single-mode fiber, you can push that exact same instant connection 6.2 miles.
It's incredible.
Why the massive difference? Why does a copper cable die at 300 feet?
Well, what's fascinating here is the physics of how the data travels. Standard network cables use electrical pulses over copper wire.
Okay.
And electricity naturally encounters physical resistance. So over a short distance, that signal degrades. It gets noisy and weak.
Right, it runs out of steam.
Exactly. Single-mode fiber, on the other hand, uses lasers to shoot pulses of light down a microscopic strand of glass.
So there's almost zero physical resistance.
None. I mean, light bouncing through pure glass doesn't degrade like electricity fighting through copper.
Oh.
That's how an operator can sit in a safe, quiet office building and flawlessly control a server located over 6 miles away in, say, a hazardous industrial site.
Or a highly secure facility.
Wait.
Okay, here's where it gets really interesting for me. It's one thing to run a single fiber cable from point A to point B.
Sure.
But the source documents mention this, Savigate P2P Manager. How do we go from one long extension cord to managing an entire facility?
Right, because in a massive control room, you don't just have one computer.
Yeah.
Out of the box, this system handles 64 servers and 8 users, which is great.
That's a lot on its own.
It is. But with that Savigate Manager, it explodes into an enterprise-class matrix of 256 servers and 32 users.
That is huge.
It acts like a massive switchboard. Any authorized user can sit at any desk and instantly tap into any of those 256 servers without unplugging a single wire.
So what does this all mean for you listening right now? Why should you care about enterprise KVM extenders?
If we connect this to the bigger picture, devices like this are the invisible physical backbone of our modern world.
Right.
The specs show a reliability rating of over 135,000 hours.
Wait, really? That's over 15 years.
More than 15 years of unbroken, continuous operation. They are what keep the air traffic control rooms, power grids, and data centers we all rely on functioning flawlessly.
Securely and flawlessly. It really redefines what it means to be at your desk.
It absolutely does.
Which leaves you with this to think about. If we are already projecting flawless, zero-latency workstation control across 6.2 miles of physical glass fiber today, how will our definition of a physical workplace change when these enterprise-grade distances expand even further?
Yeah.
Will the computer even need to be in the same state?